Step talks education. We have seen how to add our sodium hydroxide solution, dropwise until in excess to a solution under test. So we saw the different observations made with sodium hydroxide for the different cations and then their respective deductions. Now in this session we are going to see a simple summary of what we discussed, and then we shall go ahead and we look at the chemistry involved in each of those tests. So I want us to remember that our 9 cations are calcium ion, magnesium ion, zinc ion, aluminium ion, lead 2 ion, there is ammonium ion, we have got copper 2 ion, iron 2 ion, and then iron 3 ions. So let us be able to remember that these first 2 cations, as we saw with sodium hydroxide, they give us, let me use a different ink color in this case, marker color. We get a white precipitate and in excess it is so let me have here a few drops, then in excess a few drops, and then in excess, because these ones here will help us also to look at the reactions involved or the chemistry behind those observations. So calcium ion and magnesium ion gives us this observation. Now ZAP, this one gives us in a few, when we add a few drops we first get a white precipitate. Dear candidates, I believe that the word precipitate is not very difficult to write. So how I pray that you just write the word precipitate in full other than using PPT, because you may misfire somewhere. I don't want to talk about PPT anywhere. Let us use the word precipitate in full. A white precipitate, and then in excess, this one here, they are insoluble in excess. For these ones here, they are soluble to form colorless solutions. So if you have got this, just know that you have my ZAP, as we saw, zinc ion, aluminium ion, and then lead 2 ion. Now we have ammonium ion alone. This one gives us no observable change. Then in excess we get a colorless gas with a choking, irritating smell and turns moist red litmus paper to blue. If you have got this, just know that you have ammonia. This one is on heating. In excess, there is also no observable change, but then on heating, we are able to get ammonia gas, and we have to present the ammonia gas as I've put down here, using the properties of being able to turn moist red litmus paper to blue. And then with copper 2 iron, this one gives us a blue precipitate, and in excess it is insoluble. That is for copper 2 iron. Let me make some simple extension here. Then we go to iron 2 iron. So iron 2 iron gives us a green precipitate, and in excess it is insoluble, and then auxiliarily it turns to brown on standing. I told you about how iron 2 iron is never stable. If you expose it to air, it turns from iron 2 iron to iron 3 iron as a result of the atmospheric oxidation by atmospheric oxygen. So it is oxidized readily from iron 2 iron to iron 3 iron by atmospheric oxygen. Then finally, we have iron 3 iron. Iron 3 iron in this case gives us a brown precipitate. This time it is not a yellow precipitate, it is a brown precipitate. Is not yellow in color, and then it is also insoluble in excess. So this is a very simple summary of how these cations here respond to sodium hydroxide solution. Now, let us see the equations involved in this case. That is the chemistry behind these observations, or these reactions that brought about these observations here. Let us start with the calcium ion and magnesium ion. We are able to get a white precipitate when we use sodium hydroxide solution. In just a few drops, we get a white precipitate which is insoluble. When you look at ZAP, zinc ion, aluminum ion, lead 2 ion, they also give us a white precipitate. Ammonium ion gives us no observable change. We shall see why. Copper 2 ion gives us a blue precipitate. Iron 2 ion gives us a green precipitate. Iron 3 ion also gives us a brown precipitate. Any precipitate which is formed is the insoluble hydroxide of that particular cation. I repeat, any precipitate formed is the insoluble hydroxide of that particular cation. Meaning that the calcium ion so let us start with it for a few drops. For a few drops. So, calcium ion, we have to form for us the insoluble calcium hydroxide, the insoluble hydroxide of that particular cation. And where does the hydroxide ion comes from? It comes from the sodium hydroxide solution, or it comes from the very reagent. So it reacts with the hydroxide ion of sodium hydroxide to produce calcium hydroxide. And then we balance the equation. We have got 2 hydroxide ions here, and we multiply hydroxide ion by 2. That is for calcium ion. Magnesium ion, the same thing. Magnesium ion with 2 positive charges, it will have to combine with the hydroxide ions of sodium hydroxide, and we get also the insoluble magnesium hydroxide, which is formed as a white precipitate. It is insoluble, and then we multiply hydroxide ion by 2. So this is for calcium ion and magnesium ion. Let's come to ZAP. We have zinc ion also combines with the hydroxide cation, hydroxide ion, and we get zinc hydroxide. Now the fact that the the zinc ion is also a divalent cation, that is a cation with 2 positive charges, we shall also have to multiply the hydroxide ion by 2, since the 2 positive charges and these 2 negative charges will cancel and produce calcium hydroxide, neutral. Then aluminium ion. Aluminium ion, this is a trivalent cation, and we expect it to combine with the 3 hydroxide ions, which is having only 1 negative charge each, and we get aluminium hydroxide with 3 down here being the valency of aluminium. That is for aluminium ion. Then we go to lead 2 ion. This lead 2 ion will combine with 2 hydroxide ions, since it is a divalent cation with 2 negative charges. It will combine with 2 positive charges. It will combine with the hydroxide ions, 2 of them, to give us 2 negative charges to cancel these 2 positive charges. So we get lead 2 hydroxide. Then we are remaining with these ones here, and we shall have a look at them even. So let's come to ammonium ion. We see that ammonium ion gives us no observable chain. It doesn't mean that it does not form a hydroxide. It forms it only that the hydroxide is a soluble hydroxide. It is an alkali. It is not just a base, but an alkali. So ammonium ion will combine with the hydroxide ion, but only one, because it is a monovalent cation. So it will combine with 1 hydroxide ion to form soluble ammonium hydroxide. But in this case, it will not be a solid but a solution, since it is soluble, and that is what ammonium ion gives us. Then let us proceed to, in this case, let us go to copper 2 ion. So the copper 2 ion will combine with the 2 hydroxide ions, and we also get copper 2 hydroxide, which is a blue precipitate, and it is, we are going to see in this case later on in excess. Then iron 2 ion, the iron 2 ion with 2 positive charges, a divalent cation, will combine with the 2 hydroxide ions, since it is a divalent cation, and we are able to get iron 2 hydroxide. Iron 2 hydroxide. It will also be precipitated as a green precipitate. And then finally we have iron 3 ions, also combining with 3 hydroxide ions, since it is a trivalent cation, and this one gives us iron 3 hydroxide, a brown precipitate. So this is what we have got on adding just a few drops of the reagent sodium hydroxide solution. So we say that any precipitate formed is the insoluble hydroxide of that particular cation. with the exception of ammonium ion. And ammonium ion in this case gives us no observable change because the ammonium hydroxide which is formed is a soluble hydroxide. Type Talks Education. Thank you for watching.